Thank you for your hospitality, for inviting me. It's been a pleasure to be here and an honor to speak with you today about this topic of trends and opportunities in the green energy market. It's one of those things where, we were talking right before coming in here, and I was joking that I'm a chemist by training, as Dr. Yang mentioned over here, and it's, I tell people that I do chemistry, and they would generally say, "Oh, that's nice," and walk away. And now when I tell them I do air pollution and green energy, everybody's interested. So it's always so much fun to talk about this topic because it's so critical towards our planet, our sustainability, and our basic survival. So, that's okay. Okay, let's see if. Forward. So what I wanted to talk to you today is to give you maybe a little bit of a basis behind why there is a need to have green products, renewable energy, sort of some of the energy-related issues that we currently have, and talk about the energy pollution climate nexus, because I believe that's one of the critical forces of moving ahead with green energy, and the green market. As Dr. Nakahara pointed out last night, what do we mean by green? What is the motivation? Why are we doing this? And I'm sure he will talk more about that later. But what is behind this? Just saying we're doing something because it's green, what does that mean? But I think we need to get across the point of why it is so critical and why it is so important. So that's what I hope to do with my part of my discussion. Then talk about some of the issues and status of various renewable energy systems, because I think that'll demonstrate some of the opportunities that are out there, what can be done, by the research institutions here, and how can they contribute in the future, and also then summarize by looking at some future trends and prospects. Well, as we all know, if we look at future energy demand, it continues to increase. You look at all the projections, and what we're showing is a 56% increase in energy use by 2040, with 80% of that coming by fossil fuels. So there's still, this tremendous upward pressure on the need for energy. Where's this being used? Much of it is in the built environment over here. It's in residential and commercial structures, but still a tremendous amount, transportation, and the industrial sector. So this is what tends to be driving a lot of our energy needs. What about Taipei and Taiwan over here? I've modified my talk slightly from what you have in the in the booklet, and this is some information that was provided during my meeting at TPRI the other day. If you look at it, currently, Taiwan, fossil fuels make up 75% of Taiwan's primary energy consumption. This is for power. This is not for transportation. When Mr. Wong pointed out to me last night that when you look at transportation, it goes up even further. So we have a tremendous amount of imported energy needs for Taiwan, which really is an energy security issue for the future. There's continued growth in demand, and renewables account for only 6.3% of the total portfolio. It's overwhelmingly coal and natural gas over here. So there are significant energy issues and, as Dr. Yang pointed out, significant pollution issues related to this over here. Now let's consider the global resource. And this is just a resource. It doesn't mean that it's available, that we know how to use it over here. But when you look at the overall global resource, what we find is if we look at solar energy, wind, many different types of renewable energy streams and feedstocks, there's more than enough out there to meet our energy needs. The question is, how can we tap it? Now, here's an issue that's near and dear to my heart, air pollution. Okay. What we fail to consider in a lot of cases is the impact of emissions from fossil fuel consumption on human health. You look at the burning of coal, burning of oil, produces CO2, produces CO, NOx, hydrocarbons, PM 2.5. All of these products which have negative health effects. Again, where do they come from? Much of it comes from industrial emissions, mobile source emissions. Just our general need for energy produces a lot of the pollutants that lead to negative health effects. Here's some examples from the mainland over here. This was from January 29th, 2013. They hit 457 on their air quality index. Okay, extremely unhealthful. Anything above 100 is very unhealthful over here. So you can just see it's primarily PM 2.5 driven. If this was an article out of the New York Times on January 12th, they hit 755 on their air quality index. Well, this over here is primarily driven by emissions from, combustion of fossil fuels. Transportation sector, industrial sector. So is this a wake-up call? Are they going to change? Are we looking at it just from controlling these different pollutants? Now, the third issue, climate change. I know Florian's going to talk a little bit about this in his presentation because I saw him loading it over here. And I think, if you look at it, when you look at the IPCC assessment, and this is out of the recent final draft of June of 2013, warming of the climate system is unequivocal. Okay. We know we have a changing climate. I think one can argue about whether or not this is due to anthropogenic or natural forcing, but the climate is clearly changing. We need to address this. You look at the data, you see the increase in surface air temperature, surface sea temperature, marine temperature, increasing sea level, decreasing Arctic ice. All of this says the climate is changing. So we have this issue over here. What are the drivers of the changing climate? And again, what we see, CO2 emissions, methane, black carbon. Where do they come from? Where do these compounds come from? In the overwhelming majority come from the burning of fossil fuels. You look at your CO2, it comes from that. Methane, of course, does come from degradation of biogenic material, but PM 2.5, again, black carbon, fossil fuel combustion. So all of this. So we have this confluence over here of a need for energy, climate change, and pollution. And when we look at this, it's interesting. There are issues of availability and price pressure over here. When we look at a lot of the natural resources that we have, such as coal, natural gas, nuclear, there are issues related to every one of these. Many of these are water-related issues. We need quite a bit of water for cooling. When we talk about, what people don't realize is in many parts of the globe, we use more energy for water than for anything else. And similarly, we use more water for energy than for anything else. So if we can address those issues, we would have greater water availability for other needs. If we look at nuclear over here, obviously benefits the climate. You don't have the CO2 emissions, but of course there are issues related to water for cooling, and of course public safety issues. Biofuels, we have issues related to food, fuel, land, water competition, and with the other resources, again, there are certain issues. A lot of this relates to grid logistics over here. So I'm going to discuss all of these, but the important point here is we need to think about that sort of nexus of energy, climate change, and air pollution. And we look at that paradigm, I think will help focus us to see where we're going in terms of green technologies and renewable energy. Because it's not just doing it for the sake of being green, it's doing it for the sake of addressing all of these issues combined. And I think when you start looking at that, it really helps drive, the need to pursue those areas. What we're seeing here is a market increase in terms of the number of countries that have defined renewable energy targets. It used to be, in 2005, a limited number of countries. Now, In 2013, we're up to 138 countries with renewable energy targets. That's helping to drive what's going on. Here's just some examples of what we see in terms of different countries doing things. Many others, you can pull them out. You can see what they're trying to do. Investments tending to trend upwards. Of course, we see the impact of the recession, but we're now starting to see this going up again in terms of overall investments. So clearly there's a market there, and a lot of people are putting money into it. Now, this is an interesting case. This is one of the things that I tend to look at. This is from the National Renewable Energy Lab over here, U.S. case for costs of various energy systems or energy production over here. And so what I put in, wrong one, sorry. On this side tends to be the renewables. On this side is sort of the fossil fuel and nuclear. What we see, and this is the U.S. case for current systems, what we're running for coal is about 5 cents per kilowatt hour, nuclear slightly higher. In this case, this is natural gas slightly lower, less than 5 cents per kilowatt hour for fuel. For electricity production. I think that's about half of what it is here in Taiwan. Is that correct? It's about 10 cents a kilowatt hour here? Yeah, okay. So we see low. And a lot of this is driven by coal, low coal prices, low natural gas prices. Fracking has really changed things. Now what's fascinating is on this side, I've marked a few cases. This is offshore wind, this is geothermal, and this is hydropower. These are trending right about 5 cents per kilowatt hour also. Renewables are competitive. The interesting one for me, of course, is this is solar PV running about 27 cents per kilowatt hour, more expensive. Okay. But what we see when we look at these trends is, in general, significant decreases in the prices. These are getting to be competitive. They're competitive with, with natural gas. They're competitive with coal. We're almost there when we look at the prices. Of course, one thing that's really critically important and that I can't emphasize enough and really relates to what's going on here is if we're looking at these green technologies, it's energy efficiency. This is really the most cost-effective approach. When we look at costs over here, you see it's a fraction of what it costs to generate electricity. As Amory Lovins has said, from the Rocky Mountain Institute, he calls this negawatts. Not megawatts, but negawatts in terms of how you can save energy. So this is something that really needs to be pursued and considered as part of our overall energy mix is, conservation, energy efficiency. So very important point, but now what I'm going to do is really talk about a lot of the different renewable energy sources that we have out here. If you look at the global energy sources, still overwhelmingly driven by fossil fuels. The interesting part is this is not that different than the energy mix here. Look at this. 78% fossil fuels, 2.8% nuclear. You look at the others, renewables, a lot of it's traditional biomass just burning, over here. So we see that. So the true renewable aspect is still a pretty small component of the worldwide case. If we look at global installed renewable energy, world total, in this case, you can see it's still it's 480 gigawatt, total installed. The leaders are China, a lot of wind, U.S., Germany, high solar. So we see all of this being installed. So significant installed RE in a limited number of countries. This is some examples by country in terms of the top renewable energy one. And when I look at it, for me, it's fascinating because you see here the ring of fire. So you've got Indonesia, Philippines over here being pretty high. Japan also has significant geothermal. Here's Taipei, Taiwan. You've got a lot of volcanic geothermal that has yet to be tapped. So maybe that's a potential resource. So we see quite a bit, different countries, different mixes depending upon the resources that they have. Italy is surprisingly high over here in terms of geothermal. It's number 5. My wife is here in the audience, so I took her to Italy not that long ago and went to Tuscany, and I took her to a geothermal power plant. 850 megawatts geothermal, and it had a museum attached to it because it was built in 1904. It's that long. So when I go to places, I visit power plants. Many of you go visit other things. But I highly recommend going to Tuscany and visiting that power plant. Okay, if we look at biomass and look at different cases over here, what we have is a lot of this is driven by liquid fuel use demand, especially in the U.S., and this is one way of generating enough liquid fuel and energy security on that end. One thing we need to consider, of course, is the life cycle assessment, the well-to-well characterization of what we have. And this is off, so what we need to look at is the whole process for producing it, moving it. And this is often very tricky because it doesn't account for the nitrogen fertilizer issues, indirect land use, and other cases. So this often doesn't pan out as well as people make it sound. And we've done some studies looking at this, and this is the case for biodiesel and renewable diesel over here. And what we find in this case for energy return for biodiesel, it does have a positive energy return. That's good. Even better for renewable diesel over here. So many different studies. You can get data all over the place. But in general, for things like biodiesel, it does look good when you take everything into account. But for some things it doesn't, like ethanol from corn. Doesn't make sense when you look at this. Very interesting work at E-Tree that I saw the other day looking at butanol. That does make sense. Some of that. That's not probably cost competitive at this point, but that's getting there, and that's the type of thing we need to look at. Again, if we look at fuel volume, trending upwards significantly over here. This is just the U.S. case, and I think that's the case that you see in a lot of other countries. And what you're finding now is, for example, ethanol from sugarcane, biodiesel from animal fats, competitive with other, oil feedstocks over here. So we're really making some progress. But for a lot of the other ones, again, non-competitive. So there's potential here, developing other things, for example, conversion of lignocellulosic biomass to ethanol and to other species. So a lot of opportunity over there. So again, with biomass, issues of water use, fertilizer, competition for food, land availability, concerns about the contribution to global warming that you may have. So if you're looking at CO2 sequestration by plants and soils, there are issues there. And again, I think the big issue is the conversion technologies. And then I have to throw this slide in because this is near and dear to my heart. This is some of the work that I've done, and that's looking at emissions. What we often fail to consider and need to look at, for example, with things like biodiesel and other things, is how does that affect performance and emissions? And so what we see here is increase in NOx emissions. So market decreases in PM, CO, and hydrocarbons, but this increase in NOx. So that's problematic in terms of ozone. Something, again, that needs to be considered. And when you look at the fuels, look at the specs, you need to take that into account. What about geothermal? Pretty significant geothermal resources in the U.S. What we're seeing is that trending down, and we actually are right around this 5 cents per kilowatt hour right now. So extremely positive. New technologies. E-Tree, for example, had some other technologies that they were doing with their, different heat exchangers and other turbines. So lots of work there. Again, if we look at geothermal resources, what you see is the highest here happens to be the U.S. running at about over 3,000 megawatts, but that's a fraction of the available resource. One of the things that limits the resource is the proximity to the grid. You're not near the grid, so that's often limiting what you can have. But again, worldwide geothermal resources, and again, I'll go back here. Here's Japan, here's the Philippines, here's Indonesia, here's Taiwan. You have some, but limited. So real potential over here for that. One of the other things that's really driving, and this is fascinating, is enhanced geothermal systems. Basically, it's fracking to geothermal. That's what you have here. The same technologies that are used fracking for natural gas are used fracking for geothermal over here. So a lot of that is just sort of that overall resource assessment. So this is something that has changed the whole paradigm, I think, for energy as a whole. You look at the U.S., believe it or not, what's the largest producer of oil now in the world? Anybody know what the largest oil producer is in the world now? Okay, fine. U.S. now, due to fracking, for they're getting a lot of the old oil wells. Yes, Canada has the oil shale and oil sand up in Alberta. but it's the U.S. is bigger than Saudi Arabia. But Canada actually is the biggest, is the biggest exporter of oil to the U.S. The U.S. uses so much, it's crazy. Not only does it produce more than any other country, it uses way more and still has to import. And a lot of that change has been due to fracking, opening up other resources besides natural gas. So, but applied here to geothermal systems. Now, if we look at geothermal systems, there's a lot of positives and negatives over here. If you look at the energy resource, there's an enormous resource in place, limited quality. I think that's some of the issues that you have here is you're dealing with steam and not liquid. So that's an issue. Land use is not a problem. Water use is not a concern, except in some cases for cooling. Materials availability, you're not using any fancy materials, that's okay. Scale up, you can't scale up. It is where it is. So the beauty of geothermal is, of course, it's not intermittent. It's continuous over here. So in general, a pretty good resource that we need to exploit more and can be tapped. What about solar? Well, if you look at solar, again, tremendous amount of solar. Okay, even if you go through some assumptions back of the envelope, look at how much land it would take up for solar. We have the land, we have, this would not impact crops or anything, although there's some really neat things that people are doing with windows that could produce solar energy. I've seen greenhouses that could be used for both crops and solar energy over here. So there's quite a bit of resource over here. If we look at the overall solar capacity, this is the one that always amazes me because I never think of Germany as a very sunny country, right? But Germany has the largest solar resource, almost 25,000 megawatts of installed solar. Most of that is solar PV. If Germany can do it, anybody can do it over there. You look at the U.S. again, 4.5 thousand megawatts over here. China Japan 5,000 megawatts. China, so pretty significant over here. So quite a bit of installed solar capacity worldwide in countries that you often wouldn't think would have it. This is a case of just the global installation, and you see really tremendous increase. So here's another opportunity in terms of solar going in here, looking at new technologies for solar PV. You look at the overall efficiency, you see again for the efficiency of different ones. Here you've got almost 42% efficiency. That's, we've gone from just a few years ago down around 10%. Now we're pushing 40. Quite a bit. So there's a lot of work that can be done in improving the overall efficiency. Things like, you've got intermittency issues. One way of addressing that, of course, is besides solar PV, there's solar thermal. You can use that. There's a lot of installed solar thermal that's going in. One way of dealing with the intermittency, of course, is the molten salt system. And we're starting to see those being built, and those are actually cost competitive over here. So there are ways of addressing the intermittency issues for solar. So if we look at solar, resource, tremendous resource. Land, not a problem. Water use, PV, not an issue, but for solar thermal, it is an issue. If we're looking at materials availability, PV does require some exotic materials. That's a problem. Solar thermal, not an issue. Scale up, that seems to be okay. Big problem is the energy storage supply, the intermittency that we have. Cost, solar thermal is good, solar PV is not. So that's a downside over there. Life cycle looks good. Overall payback, PV, only because it's subsidized. Solar thermal, trending much better. What about wind? Okay, if we look at a lot of offshore wind that we have, and to me, you look at these things, and these turbines are huge. I mean, this is a 747-200 is basically the size of one of these. That's clearly an issue, and this is, when they're getting bigger and bigger all the time here. If we look at electrical capacity, China, almost 64,000 megawatts of installed wind capacity on the mainland over here. You look at the U.S., 47,000 megawatts of installed capacity. Just huge. Germany, again, very high. So you can see significant. You've got a lot of North Sea installed capacity over here. You look at the trending in the U.S., again, trending upward. Quite a bit of installation for what we have. But the problem is variability. The wind's, highly variable, blows different directions, different wind speeds. That, here's an example from California in Tehachapi Pass by LA. So some challenges with wind, the variability, overall capacity here, the need for reserves to for load balancing for the grid. It's non-dispatchable, and many of the best resources are remote from load centers. They're offshore, so it's not easy to bring it in. Look at the resource. It's great. Land use. There are issues, of course. People don't like having these in the backyard, both for noise and other cases. Materials availability, no water use issue. That's the great part. Materials availability tends to be pretty good, although there's some exotics that are used now in some of the turbines. Scale up is fine. Downside is that variability that we have. Cost trending lower. It's really these are cost competitive over here. Life cycle is good. Minimal other issues. What about hydro? What we find is you don't have very much energy density with hydro, but it's a really easy resource to use. We've used in a lot of cases. The problem is we've used most of the good cases, worldwide. Also, there are issues, of course, with environmental issues on how dams affect the overall ecology that you may have. So when we look at hydro, what we find over here is the resource is limited. We really can't develop very much more of what we have. Land use is an issue with that. Water use is really not a problem. You still have the water. No materials issues. You can't scale up because it depends upon the sites that you have. It's 24/7. It can provide base load similar to geothermal, so that's extremely positive. Costs are favorable. Life cycle is okay. There are issues with some anaerobic decomposition in the reservoirs, producing methane, so that's somewhat of a problem. So biggest issue is that the locations are limited. What about advanced water power? Everybody talks about it, right? There's a lot of resource there. Well, here's an example of, these are the current locations of various both wave and tidal sites. All of these are demonstration projects. None of them are really functional online. Okay, they're all demo, so they're not producing anything. So this one, I think, is a long way off for what we have. How do you deal with those intermittency problems? Well, there are ways of dealing with it with load management, communication, smart grid. We are starting to address those, but it's still a challenge for what we have. Some other ways of addressing it, of course, and this is another opportunity, developing other battery systems, other storage systems that you can have, flywheels, capacitors. Pump hydro is a common technique. I mean, there's a significant amount of pump hydro right here. But again, it's a challenge, and it's something that needs to be addressed in the future, especially if we're going to increase the amount of wind and solar that we have. One thing I think when I look at this overall is we're still going to need fossil fuel. Hopefully we can minimize it, but it's still necessary for overall load balancing. And of course, one of the challenges is, you can do the load balancing pretty well with the, with the gas cogen. That works pretty well. But if you're going to coal-fired plants or other things like that, nuclear, can't do it. So there are some real issues, but we're still going, I think, to need some of this in the future, as just for load balancing for grid issues for what we have. So where are we going over here? If we look at it, this is the U.S. case, but this is pretty similar to worldwide. We tend to see it trending upward in terms of overall energy needs. A lot of that in the U.S. is being filled by natural gas, again, due to fracking and other things. Coal has gone down, still going up. Nuclear, probably not increasing very much. Renewables, increasing significantly. But we still, in the future, have this need for energy. They continue to grow. When we look at natural gas, coal, all of these have environmental impacts. When we look at the overall resource, though, we have a large renewable energy resource available. And based upon what I showed you, I think a lot of the generation issues can be addressed with appropriate technologies that you and others can develop over here. One of the main points, though, still is conservation, energy efficiency. That's another, that's getting back to our negawatts. That's bringing this down to what we really need. And that's another crucial part that we have to remember. And when we're doing this, we need to consider the basics for a sustainable, secure energy future. And these are the what are often called the 5 E's. I don't know how this works in Chinese, but in English it works. What we have here is, we need to consider the environment, energy, the economics, equity, and education. All of those are critical in terms of developing a sustainable energy future. We often have these discussions. We need to look at the facts. We need to educate people. We need to consider, all of these components. It's not just let's put something out there and let's make money in the short term. Let's look at the impact on the environment. We need to consider our energy security. I'm not denying that over here. We need to look at the economics. But we also need to look at, the equity and the fairness. We talk about things like environmental justice and other things. These all need to be considered. So what are the prospects? Well, when we look at this over here, clearly there's resource availability. When we look at the renewable energy side of the ledger, and the green energy side, we have that resource. As we go, I think environmental concerns will continue to be a driver. It'll be, impact of CO2. There'll be impact of PM 2.5. There'll be ozone. All of these are critical in terms of human health and welfare. And I think that will continue to push a lot of the policies that we have. So there's a continued implementation of new policies by many countries. That's very positive. We're closing in on cost parity. Again, very positive for what we have, especially with the technologies that we have. Some issues, though. Many forms are still subsidized. We look at the solar PV. That's still subsidized. There are the issues of intermittency for solar and wind. Those need to be addressed. Current natural gas prices are remarkably low due to fracking and other things. This is true for, we see it worldwide. That is really, that's keeping us from changing. That's sort of an artificial case. What happens when that changes and those prices go back up? But for now, that I think is limiting, what we can do in terms of renewable energy and green technologies. And one of the real important parts for me is we do not account for the subsidies and externalities of fossil fuel use. We don't account for those health costs due to PM 2.5 emissions from fossil fuel burning. So, for example, in the U.S., the estimate is we have about 66,000 excess deaths due to PM 2.5 in the U.S. Of that, 24,000 is attributed to coal-fired power plants. So 1/3 of the excess deaths due to PM 2.5 is just attributed to coal combustion. Most of the rest is due to transportation. We don't account for those costs. We need to account for those. When we really do that honestly and push that to other people, I think that will make a big difference in terms of driving that green energy sector over here. So overall, I'm optimistic in terms of what's going on here. I think it's taking a little longer than I'd like to see, and probably you'd like to see. But I think everything is pointing in the right direction. And what I'd like to leave you with, really, the bottom line when I go through all of this and look at the science behind it and look at these other, the data, renewable energy and green technologies are clearly critical for meeting our future energy needs. It's a major component of what we can have. It can be expanded significantly over where it currently stands. And so this really, when we look at it, it offers the potential for energy security while addressing the issues we have with climate change and air pollution. So I think it's, I think we've got a great potential here, and renewable energy, green technologies are a critical way to go to addressing these needs. So with that, I'd like to thank you for your attention. Thank you for your hospitality and for inviting me. And I will take any questions. So thank you.
Thank you so much, Professor Gertler. Actually, I didn't mention to you, I was the Deputy General Director of the Energy and Environmental Laboratories of ITRI. So you mentioned, actually you collect some cases from ITRI. I quite agree with you because I also serve as the Deputy Secretary of the Renewable Energy Office of our Bureau of Energy. Actually, Professor Gertler gave us a very, very comprehensive. I like your presentation so much because for the renewable energy, probably we can have the expectation, but normally we have too much expectation on it because we also have need to have some measures, some different means for implementation. And I love you. That especially those forms, you give us a summarized form on each renewable energy. That's very important because we have to consider about the different kind of things. Water usage, land, life cost, I would say life cost accounting and life cost, life cycle impact assessment, different kind of things. We have to consider a lot of things. So probably we have time for just one question. Okay, Professor Liang. Actually, Dr. Liang, he is also an expert in the energy economy.
Yes. I fully agree with Dr. Yang. The remark. It's a quite in-depth and quite extensive study and very good, excellent presentation. And I think some of the data, maybe it's only it's come from U.S., such as the page. I don't know about the cost of a new generation.
Yes, that's U.S. data. Yes.
Data. Okay. So gas combined cycle.
Yeah.
We use LNG. It's very different.
Right. It is very different.
Also, I found that you have data on efficiency. It's 3.4 cents US dollar. So how to calculate efficiency? Because efficiency cost, okay, different. I don't know how do you calculate that.
Yeah. What that was looked at is that it was almost done with sort of a partial life cycle assessment over here, where they're looking at the overall production and then the estimate of the energy savings. So what's the cost to implement that versus the cost to produce, and that then produces a certain amount of energy savings, assuming implementation. Then what would you save in terms of your power production over there? So that's how that was looked at over here. What's the overall, by producing it, by implementing it at a certain level and a certain efficiency over here, how much does that, reduce the energy need? And that's how the cost was estimated in that case. But yes, I that's one that can be a little tricky, and I was talking with Lichi, Dr. Wen last night, saying she's the economist, I'm the chemist. Economists make all these assumptions over here, and that's where the economists come in and put in their assumptions. But yes, it basically looks at the energy savings versus the total cost to implement some of these conversion technologies. And if you look again, some of the things that I saw at ITRI yesterday, with some of the the lighting systems that were developed, those are ones where you can go through and you can run and you can start looking at the numbers and seeing how much they help. But
some of the estimation, the energy saving technology, the cost according to McKinsey, is maybe minus.
No. It's I fully agree and fully understand. What you're saying, and that's we need to look at that overall accounting. That's why I say when we look at these things, let's really level that playing field. Let's make sure, yes, we do, for example, subsidize a lot of renewables, but we also subsidize, fossil fuel use. How do we account for energy efficiency? What does that mean in terms of those costs? that's a whole area that we really need to explore and maybe formalize some of the methods so we can do that comparison. And I think if we start doing that, that will help drive this field even more, because when you understand the costs of the current way of doing business, that will then say, okay, if we look at this other new way of doing business, we can then see how appropriate it is. And I think that will drive the green economy. You know, when we fully account for the true costs of all these other things, and fully, as you point out, understand the costs of things like energy efficiency and other aspects. Okay. So thank you for the question. That's a very good point.
Yeah, good. Probably we have to move to the next speaker. Let's thank Professor Gertler again. Very good presentation. Thank you.
Well, thank you, everybody. Thank you for listening.